Okay, ma? So the last topic in wave optics is diffraction of light and polarization of light, ma? So these two are wave properties of light. Okay, that's why it is called as wave optics, no? In ray optics we study straight line properties. In wave optics we study wave properties of light. Okay, ma? So what is meant by diffraction? Bending of light into the shadow regions is called as diffraction. So what is the meaning of this one? See, ma, here, for example, if this is an obstacle, okay, and consider plane wave fronts are traveling like this. So these are the plane wave fronts. Okay. Now here there is a screen. So this is an obstacle with a small opening. And here there is a screen. Then what do you expect? మీరు ఏం ఎక్స్పెక్ట్ చేస్తారు చెప్పండి. So we expect that this light goes and falls on the screen. This is what we expect, no? Are you able to understand? So actually here a light should be present. This region should be brighter. And here shadow should be present. Here also shadow should be present. Here also shadow should be present. But actually what happens is that light enters into shadow region also. Okay. This property is called as diffraction. Are you able to understand? No? So actually we expect that only this much part should be brighter. Remaining should be darker. Shadow should be present. But because of diffraction principle, what happens is that light enters into shadow regions also. What can be the reason? Reason is very simple. See, ma. For example, this is the obstacle which we are placing. Clear? So this is the screen. Okay. So here we have, see, ma, this wavefront which enters this what you call passage, this gap. So this wavefront, every source behaves like a point source. No? What Huygens principle, in Huygens principle what we studied, every point on the wavefront behaves like a secondary source of light. So therefore, this wavefront also, and all the points on this wavefront also, they behave like secondary sources of light. Are you able to understand? So if you take this light, which is present on the wavefront, it will propagate like this. No? It will propagate like this. Similarly, this point also, it will propagate like this. Are you able to understand? So actually light is not present only here, but light is entering into shadow regions also. This is the reason. Are you able to understand? Understood now what is the reason? So every point on the wavefront, it behaves like a secondary wavefront. So this secondary source of light, again it spreads in every direction. So instead of falling just in that region, it spreads into shadow region also. That principle is called as diffraction of light. Okay. Similarly, if I take one more example, see, consider this is plane wavefront. Plane wavefront. Okay. And here I am placing an obstacle. This is an obstacle. Dominate. Okay, ma? So this is the obstacle and here a screen is present. Now can you say what can I expect? చెప్పండి ఏం ఎక్స్పెక్ట్ చేయాలి నేను? ఐ ఎక్స్పెక్ట్ దట్ హియర్ షాడో షుడ్ బి ప్రెసెంట్. హియర్ షాడో షుడ్ బి ప్రెసెంట్. దిస్ ఇస్ వాట్ ఐ ఎక్స్పెక్ట్. అండ్ రిమైనింగ్ రీజన్, దిస్ రీజన్ ఆల్సో షుడ్ బి బ్రైటర్. దిస్ రీజన్ ఆల్సో షుడ్ బి బ్రైటర్. This is what we expect. But what happens is that when this wavefront goes and falls on this obstacle, so here there is a source of light, here there is a source of light, no, which is a part of this wavefront. This wavefront incidents on this one, no, ma? So here a source of light is present, here a source of light is present, which are these two light rays. So now they start spreading in every direction. Are you able to understand? They start spreading in every direction. So actually, instead of shadow creating here, only this much amount of shadow is created. Only this much amount of shadow is created. Are you able to understand? So therefore, in this phenomenon and this phenomenon, what is the common thing which we observe? Common thing is light is entering into shadow region. Light is entering into shadow region. Thus, principle is called as diffraction of light. Okay, write down. And it is possible only if light is traveling in the form of waves. No, if light is traveling just like a particle, it is not possible. So here this is spreading light waves. Then only it can enter into the shadow region. So diffraction principle proves wave nature of light. Okay, ma? Right. See, ma. So now we are studying diffraction through single slit. See, ma, listen here. So this is a cardboard through which a single source of light is entering, and it diffracts through this small hole. Are you able to understand? And you can find this type of pattern on the screen. Pattern in the sense, this is the graph of intensity. So at the center of the screen, you can see a very bright fringe and whose width is also very large. In YDSC, what we have studied, in YDSC, what was the nature of fringes? So width of bright fringe, width of dark fringe, they were equal. No? Okay? But here it is not the condition. In the case of diffraction, central bright fringe will be very, very wide, and it will be very bright also. Remaining fringes will be very dull. And as you move away from the center, brightness reduces, width also reduces. Okay? So here only central bright fringe will be very bright. Remaining fringes will be, they will not be so bright. Okay, ma? So see. So therefore, if I take the magnified image of this what you call figure, then figure appears like this. Are you able to understand? See, my width of the slit is very, very, very small. But for your understanding, I have drawn it as a very big, what you called, very big slit. Okay. See, my here I want parallel rays of light. How can I obtain parallel rays of light? This is a point source, no? This is a point source of light giving radiations in every direction. So this point source of light, these light rays, they are passed through a lens. So now can you say point to source should be placed at what distance from the lens so that I can get parallel rays? So distance between this lens and this point source, distance should be focal length. If object is present at focal length, then only light rays after passing through the focus, they travel parallel to principal axis. Already we have studied. No? So at this distance, I place one converging lens, which is called as concave lens. Now light rays, they are traveling parallel through the slit, through the small hole. Now after this, again I am placing a bigger lens. So this is lens L1 and this is my lens L2. Okay, ma? So this is again converging lens. No? So therefore what I see, so most of the light rays, they go and they converge at the center of the screen. Okay. So this center of the screen here, the fringe which is formed, it is called as central bright fringe. Okay, ma? What is the fringe formed here? Central bright fringe. So therefore what is the point I can write? At point O, okay, ma? The fringe formed is wide, brighter, okay, ma? And is called central bright fringe. Okay, ma? Now can you say why it is a central bright fringe, ma? Yeah, dark fringe form out together. Why bright fringe has formed? Can you say anybody? Reason I want. What I am asking you here, I am saying at this point bright fringe is formed. No? My question is, why can't dark fringe be formed? Anybody? What is the condition of formation of bright fringe and dark fringe? Bright fringes eppudu form avutayi, dark fringes eppudu form avutayi? So when all these light rays, when they are interfering constructively, then here you will see a bright fringe. Are you able to understand, ma? So therefore at the central bright fringe, all the light rays, they are interfering constructively. Constructive interference is happening. Okay? So therefore here you will see a bright fringe. Now see, ma, here in this gap a wavefront will be present. No? In this gap what will be present? Light wavefront is present. No? So every point on this wavefront, it behaves like a secondary source of light. No? Every point on the wavefront behaves like what? Secondary source of light. So most of the light is concentrated here. Some of the light will reach this point also. No? Some of the light will reach the above point, so light will be continuously forming on the screen. So bands will form. Okay. Now the point is that when some of the light rays, when they have traveled and when they reached this point P, now the question is here, bright fringe is formed or dark fringe is formed. That I don't know. No? Are you able to understand? No? At the center, definitely bright fringe. At the center, definitely bright fringe will be formed. At the next positions, when other light rays, when they go and reach there, Sima. So these point sources, how they behave? These point sources which are present in this gap, they behave like a secondary sources. No? Are you able to understand? No? They behave like secondary sources. Clear? So some of them they interfere constructively, some of them they interfere destructively. In YDSC experiment we have drawn. No? So same type of pattern you can observe here also. Are you able to understand? Okay. Now the point is that the light rays which are reaching point P, whether they are interfering constructively or whether they are interfering destructively, that I don't know. Okay. So what I do is, so this width is there, no? Width of this slit, this I can call it as a D. So here what is a D? The width length. In YDSC what was called a D? Distance between two slits. But here D is called as width of the slit. Are you able to understand? Ma? Now if this is pi, so these light rays, second light rays, they are making an angle of pi with respect to horizontal. No? So therefore this D also, I will split this one into two components. Clear now? So this is D. So if this is pi, this angle is also pi. So observe very carefully. This angle is also pi. Okay. This is D. Then what is this one? D sin theta. This one? D cos theta. That's all. No? Are you able to understand what is happening? This is D ma. Width of the slit. Now this D I am splitting into two components like this. So if this angle is pi, this angle is also pi. Okay. So this is adjacent side D cos pi and this is opposite side D sin pi. Okay. Now in this diffraction experiment, this length D sin pi is nothing but path difference between first wave and second wave. Are you able to understand? See. So observe this length from here to here. Similarly observe this length, not from here to here. So this length and this length will be almost the same. Are you able to understand what is happening? So starting from this point to up to point P. Next from this point to point P, their lengths will be same. So therefore what is the path difference between first wave and second wave? Path difference is nothing but this much length. This much length. Are you able to understand? And that length is nothing but D sin pi. Are you able to understand what is happening? So therefore D sin pi is the path difference. Okay. What is meant by path difference already we have studied, no? Path difference means what? Path difference means difference between distances traveled, that is called as path difference. Okay, ma? So path difference between first wave and last wave is how much? It is D sin pi. This you should always remember. Where D is called as width of the slit. Are you able to understand, ma? Okay, now see. So when D sin pi is equal to lambda, path difference how much I am taking? Lambda. So when path difference is lambda, waves, will they interfere constructively or destructively? Chappan. Constructively. That's all. No? Sima, when D sin pi is equal to lambda, lambda means one wavelength extra. No? Half wavelength is not extra. One wavelength extra. One wavelength extra means a trough superposes on trough, crest superposes on crest. So it should be constructive. But in diffraction, when D sin pi is equals to lambda, 2 lambda, 3 lambda, interference is destructive. This is one exception which you should study. Interference is destructive. It means dark band will be formed. Dark band will be formed. Are you able to understand? Ma? So actually when path difference is lambda, 2 lambda, 3 lambda, bright fringe should form, no? But in diffraction experiment, dark band will be formed. Okay? What is the reason? Let us try to understand by taking an example. Okay? Sima. So listen very carefully. Now this is the slit width. This is the width of the slit, and consider this is the screen. Okay, so this slit width I will divide into two equal halves. I will divide this one into two equal halves. So total length is d, no? So this is d by 2, this is also d by 2. Now distance between these 2 points is how much? In terms of lambda, we have taken path difference is lambda, no? When one wave from here, one wave from here, first wave and last wave, when they go and interfere on the screen, see, where is this line on the first wave, no? Where is this line on the last wave? Okay, ma? When these two go interfere and fall here, then what is the path difference we have taken? Path difference is lambda. Arthamautundi kada? So it means the path difference between this point and this point is how much? Lambda. So I take one source of light here, one source of light here. So difference between these two is lambda. Are you able to understand? Okay. Now can you say what is the path difference between these 2 points, ma? Huh? Lambda by 2. Path difference between these 2 points? Lambda by 2. Are you able to understand? Arthamautundi kada? Total lambda I have divided into 2 parts. One is lambda by 2 and the second one is also lambda by 2. Now see. Now you take this source of light and this source of light. Now can you say what is the path difference between them? Lambda by 2. Path difference between this one and this one is lambda by 2. This one and this one is lambda. But I am discussing about this one and this one. How much? Lambda. So these two interfere destructively, no? Because path difference is lambda by 2, how they will interfere? Destructively. Lambda by 2 means half wave is extra, no? పొద్దున క్లాస్ నీట్గా విన్న వాళ్ళకి మాత్రమే అర్థమవుతుంది, మిగతా వాళ్ళకు డబ్బాలో రాలేసి కొట్టినట్టు ఉంటుంది అన్నమాట. అర్థమవుతుంది కదా? సిమా. సో when path difference is lambda by 2, for example here 3 waves are traveling, here 3.5 waves are traveling, so they will interfere destructively. Okay, now see. So I will take one more source of light exactly below this one, and one more source of light exactly below this one. Now what is the path difference between these two? Lambda by 2. So they also interfere destructively. Are you able to understand? So you take one more point below it and one more point here. These two are sources of light, no? And what is the path difference between them? Again lambda by 2. So they also interfere destructively only. So understood now why it is behaving destructive interference? Clear, Nama? So therefore in a diffraction experiment, when path differences are in multiples of lambda, lambda, 2 lambda, 3 lambda, 4 lambda, n lambda, then interference is always destructive. Reason you have understood, Nama? You can divide the slit into 2 parts. Okay? So you take one light and here one light. Path difference between them is half, lambda by 2. They will interfere destructively. So like this continuously all the waves they will interfere destructively and finally a dark band will be formed. That is the reason. Are you able to understand? So write down. Clear, ma? So therefore, that's it. Make a note up to there. Inka. So, now see here. For example, if I take d sin phi is equal to lambda. D sin phi is equal to lambda. So therefore, sin phi value is so much, and this is what position? No, this is the position of first secondary minima. What I call this one? This is the position of first secondary minima. Minima means what? Diffraction. First diffraction interference will come d sin phi. What is the first one? First secondary minima. What is the primary fringe. Remaining all of them are secondary. Whether it is bright fringe or dark fringe, all of them they are secondary. So this is first secondary minima. So therefore I can calculate angle also. How can I calculate? Sin pi is equals to lambda by d. So therefore pi is equals to sin inverse of lambda by d. So this is the angle Angle means this angle. This is the angle where I will get first secondary minima. Okay. Secondary minima. So itla questions adutadu navadu. Secondary minima. Where I will get when d sin pi is equals to 2 lambda. So therefore sin pi is equals to 2 lambda by d. Clear ma? Therefore pi is equals to sin inverse of 2 lambda by d. So at this angle I will get secondary minima like this. Understood no? Position समझ में आता है नहीं क्या? हाँ एक here first I will get first secondary minima, then somewhere here I will get second secondary minima, third secondary minima like this. So those angles we are measuring. So this is the angle for first secondary minima, this is the angle for second secondary minima like that. Okay. Now see, when d sin pi is equals to lambda plus lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, interference is constructive. Interference is what? Interference is constructive. Okay. So I will get a white band or bright band. Are you able to understand what is happening? 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, 9 lambda by 2. At these values, when path difference is this much, then I will get bright band. Okay. So now let us try to understand what is the meaning of this one. See, this one completed. See. So I will take the first one. D sin pi is equals to 3 lambda by 2. Clear no? What is this one? This is the position of first secondary maxima. First secondary maxima. Maxima means what? Constructive interference. Okay. Now see. So if this is the slit width, this is the slit width. So listen very, very carefully, otherwise you cannot understand. This is the slit width and here is the screen. So 3 lambda by 2, I can write it as lambda by 2 plus lambda by 2 plus lambda by 2. No? I can write like this. No? Clear no? Lambda by 2 plus lambda by 2 plus lambda by 2, 3 lambda by 2. So therefore, I will divide this figure into 3 parts. 3 parts. Divide this figure into 3 parts. Now if you take the path difference between first source and last source, then how much it is? It is 3 lambda by 2, no? 3 lambda by 2. Are you able to understand, no? Path difference between first source and last source is 3 lambda by 2. So now I am dividing this gap into 3 regions. First region, second region and third region. Okay, ma? Now can you say what is the path difference between these two? Lambda by 2. Path difference between these two? Lambda by 2. Path difference between these two? Lambda by 2. That's all. No? Clear, no? Now see. Now you take one source here and one source here. Now can you say what is the path difference between them? Lambda. See, this is lambda by 2 plus lambda by 2. Total lambda, no? Are you able to understand? So these two, how they will interfere? Constructively. Okay. So you take the next source of light. This one and this one. What is the path difference? Lambda. So they will also interfere constructively. You take the next one. This one and this one. These two also interfere to form constructive interference. So remaining these are there, no? They will interfere destructively. The path rays which are present between these two bands, they will interfere destructively because path difference between them is lambda by 2, no? Are you able to understand what is happening? It means out of 3, for example, I can say 3 spaces or 3 gaps. 2 gaps are interfering constructively, 1 light is interfering destructively. So finally it will be a dark band or bright band? Huh? Definitely bright band. Clear ma? I have split the gap into 3 regions. Two regions are interfering constructively. One region is interfering destructively. So definitely finally there will be a white band only, but brightness will be reduced. Brightness will be reduced. What is the reason? Because one region is definitely it is interfering destructively, no? So brightness will reduce. So that is the reason why continuously brightness reduces in diffraction. But in the case of IDSC, all the patterns were uniform. But here it is not like this. Only central bright fringe will be very bright. And if you go to next one, brightness reduces. Next one, brightness reduces. So like this, brightness continuously reduces. Are you able to understand what is happening? This is the reason. Okay, ma? So therefore, at 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, I will see constructive interference. Actually, in YDSC, they should interfere destructively, no? 3 lambda by 2 means what? 1 lambda by 2 is extra. Clear, no? 1 lambda by 2 is extra means a trough and crest should superpose. And we should get destructive interference. But here it is constructive. Are you able to understand, ma? That is the point. So therefore, what I write, I will write first secondary maxima. First secondary maxima where I will get d sin pi is equal to 3 lambda by 2. So therefore, sin pi is equals to 3 lambda by 2d. Therefore, pi is equal to sine inverse of 3 lambda by 2. So at this angle, I will get the first secondary maxima. Okay, ma? Like this, you can calculate second secondary maxima, third secondary maximum. Angles you can go and calculate. And questions can be asked on this one. Okay? Right down. See, ma. So next we are discussing about width of this central maximum. Already we studied that only central maximum will be very large, no? Its brightness, its width will be very large. Remaining fringes, they will be very small. And as you move away from the center, brightness, intensity, thickness, width, everything will be reduced. Okay? Now see. So already we have studied that first secondary minima. This is the position of destructive interference, no? So here I will get first secondary minima. Next followed by second maximum. That is why it is called first secondary maximum. This is primary maximum. First secondary maximum. Then again followed by second secondary minima. Then again followed by second secondary maximum. Like this you will go on, you will getting the minima and maximum. Okay, now see. So first secondary minima when I will get first secondary minima. Okay, ma? Already we studied d sin pi is equals to lambda. Do you remember? First secondary minima we will get at this position only, no? D sin pi is equals to lambda. So therefore, sin pi value is equals to lambda by d. Okay, ma? Pi is very small. As pi is very small, sin pi is almost equal to pi. So therefore, pi is equals to lambda by d. I can write like this. Okay, ma? See, ma, these fringe widths will be very small, ma. Okay? In comparison to remaining fringes, it is very large. But if you take on a screen, it is very small. So therefore, this angle pi is very small. So instead of sin pi, you can take just pi only. Are you able to understand? Similarly, if this distance, if I consider x, then this distance also will be x only, no? X. Now what is this distance? This distance is d, no? Very good. Now if you take tan pi, okay, ma? Tan pi is equals to opposite by adjacent, no, ma? Can you say opposite is what and adjacent is what? X by d, x by capital D. Now again pi is very small, no? If pi is very small, instead of tan pi I can take just pi. Pi is equals to x by d. Are you able to understand, no? So here I got pi is equal to lambda by d. Here I got pi is equal to x by d. Equate them. Clear? So therefore, lambda by d is equals to x by d. So therefore, what is x value? X value is
lambda capital D by small.
So lambda capital D by small d. Okay, ma? So this is x value, but I am not concerned about x value. Okay, ma? So linear width of the fringe is x plus x 2x, no? What is the linear width of the fringe? X plus x 2x. So therefore, linear width is how much? linear width is x plus x, which is equal to 2x. So therefore 2 into lambda capital D by small d. So 2 lambda d by d is the linear width of the central maximum. అర్థమైందా ఎలా చేసాము? క్లియర్ మా? Similarly, if I want angular width of secondary maximum. Okay ma? So angular width is very simple. Already we know that d sin pi is equals to lambda. So therefore sin pi is equals to lambda by d. Diffraction experiment. Okay, SIMA. So next we are studying about polarization of light. So what is meant by polarization, SIMA? Restricting a wave to oscillate in only one, instead of phase I better write one plane. That is called as polarization. Okay ma? SIMA, consider this is a transverse wave. Okay, so this transverse wave, it is passed through an axis. So this is a wooden frame. So this is the transmission axis, and wire can easily oscillate in this axis, no? In this wooden gap which is present, wire can oscillate, no? So no problem, it will pass the what you call this transverse wave. Transverse wave is passed very easily. Now instead of placing this axis like this, if I place the axis like this, now this wave cannot pass. So that is the second condition. Are you able to understand? Instead of placing the axis like this, if I place the axis like this, then transmission will stop. So wire no longer it is performing wave motion. Similarly, if I take a wire and if I oscillate like this, like a hexagon, what you call this one, helical path. Helical path we have studied in magnetic effects, no? So moving in a straight line as well as it is rotating also. So if I oscillate a wire like this, and if I pass through this type of transmission, now here wire is oscillating in how many dimensions? It is oscillating along z-axis also, it is oscillating along y-axis also. Two oscillations are present, no? But this transmission axis, it will pass which transmission? Will it allow z transmission or y transmission? Z ఇలా ఉంటుందిరా, ఇలా ఉంది ఇది transmission axis. Transmission axis is like this. Z is what you call restricted, no? Only Y transmission will be allowed. Are you able to understand? It means here this wire is oscillating in 2 dimensions. We have restricted its oscillation only to 1 dimension, 1 plane. So this is called as polarization. Are you able to understand? Ma? Similarly, light also can be polarized. Ma? So now we will study about polarization of light. Okay. So in polarization of light, see how light is made up of? Light is made up of electric fields and magnetic fields. Electric fields and magnetic field. Okay. In electromagnetic waves you should have studied, light is a combination of electric field as well as magnetic field. But we will study only electric field. We study only electric field because it is responsible for vision. It is responsible for vision. Are you able to understand? Ma? Now how electric fields will be present, Sima? For example, if this is the direction of light, electric fields will be present in every direction. Ma? Clear? So like this electric field will be present in every direction. Like this. Are you able to understand? So electric lines of force, they will be present in every direction when light is traveling. And magnetic field is also present, but we are neglecting magnetic field. So what I do is, I will convert these electric fields in every direction to only 2 directions. I will take the vector sum of all of them and this is one electric field, and a dot represents another electric field. So this is one electric field, so this is the dot representing another electric field. So this is one electric field, dot represents another electric field. Okay? Sima, the oscillations in all the dimensions, we are converting into only 2 dimensions. We are taking the vector sum of all the oscillations. Anni vaipula oscillations unnai kada. Instead of that, we are assuming as if only 2 dimensions are present. One dimension is present in the plane of this board, another dimension is present in perpendicular direction to the direction of the board. So we are taking the vector sum of all these electric fields, and we are assuming electric fields are oscillating in this direction. Only one electric field in the plane of the board, one electric field perpendicular to the plane of the board. So dot represents this kind of field. This line represents this kind of field. Okay? ఇవన్నీ తీసుకోవడం కన్నా జస్ట్ ఇది మనం తీసుకున్నాం. Are you able to understand? So what we write here, so we take the sum of all electric fields, clear ma, and represent in only 2 dimensions. Okay ma? One in the plane of board, one in the plane of board, and next, and the second one is perpendicular to plane of board. Okay ma? One is in the plane of the board, second one is perpendicular to the plane of the board. Only 2 electric fields we are considering. One field is like this, one field is like this. That's it. Okay ma? Make a note. Okay. Now see. So Polaroid. What is a Polaroid? Polaroid is a tourmaline crystal which is made up of material tourmaline, and it has a transmission axis. Transmission axis means what? That axis through which electric field can travel. That is called as a transmission axis. Are you able to understand? So electric field along transmission axis is passed, and the remaining fields, they are filtered. What is the meaning of this sima here? So what is this kind of electric field? What is this light? This is called as unpolarized light. Unpolarized light. Why I call it as unpolarized light? Chepandi. Because electric fields are present in every dimension. Are you able to understand? But when I make it to pass through a Polaroid, and Polaroid has a transmission axis, so therefore that electric field which is parallel to the transmission axis, only that will pass. Remaining all the electric fields, they will be filtered. Now here who is getting filtered? Dots are getting filtered, no? And only the electric fields which are in the plane of the board, they are traveling. So this kind of light, I can call it as plane polarized light. Plane polarized. Are you able to understand ma? So plane polarized means what? Now electric field is oscillating in only one plane. What is that plane? Plane of the board only. Remaining electric fields, they are filtered. Are you able to understand ma? So this is the principle of a Polaroid. Okay? Right. Sima here, listen. Sima, if I take 2 Polaroids, so first Polaroid is called polarizer, second polarizer is called as analyzer. These are the names which we are giving. Are you able to understand? So if the angle between 2 transmission axes of Polaroids is theta, what is meant by transmission axis? Sima. So this is the transmission axis of one Polaroid, and if second Polaroid is present like this, then they are present at what angle? 0 degrees, no? But if I bend this Polaroid by a small angle, that angle is called theta here. Bend ante itla bend cheyadam ledhu manam. Are you able to understand ma? We are bending like this. So that angle is the angle between transmission axis of first Polaroid and second Polaroid. Are you able to understand ma? Bending ante itlagani itlani kaadu. We are bending in this direction. Okay ma? Now see. So therefore, then what I see, then the intensity of light coming out of the analyzer. What is meant by analyzer? Second Polaroid. That is equals to how much? I is equals to I naught cos square theta. And I naught is not the intensity of light given to polarizer. I naught is the intensity of light after crossing the polarizer. అర్థమవుతున్నాయి స్టేట్మెంట్స్? సీమా, వాట్ ఈస్ ద ఇనీషియల్ ఇంటెన్సిటీ ఐఎమ్ గివింగ్? 2I naught. 2I naught has become I naught. Why? After passing through the first Polaroid, 2I naught has become I naught. What is the reason? Half of the electric field is filtered, no? So therefore only I naught is present. Clear, no? Then, and now what is this one? This is called as polarizer. Okay, ma? And this second Polaroid is called what? It is called as analyzer. So angle between transmission axis is how much? Pi or theta. Then the resultant intensity after crossing the analyzer is, this is the answer, I naught cos square theta. Understood, no? So many times questions were given on this. So try to understand carefully. See ma, here now polarizing we have studied by using polarizers, no? Okay, by using polarides, how to polarize light, that we have studied. Now we are studying polarization by the concept of reflection also. Okay, see what happens is, when you incident light at 0 degrees or 90 degrees, then you don't find any polarization, no polarization. Are you able to understand, ma? But if you incident light between 0 and 90, then you can find some polarization in the reflected light. See, any light which enters into medium, always some light is reflected, some light is refracted. అర్థమవుతుంది కదా? It always happens, but we study them individually. But whenever light is incident on a medium, so see, my light is bending towards the normal or away from the normal? Towards the normal. So it is entering rarer medium or denser medium? Denser medium, no? Definitely this is denser medium. Are you able to understand, ma? Then only light bends towards the normal. Now see. So when this is the light which is falling, what is this light? This is unpolarized light. Unpolarized light. Clear, no? When this unpolarized light falls on any medium, some of the light is reflected, some of the light is refracted also. Now you see that there is very slight amount of polarization, no? So here you don't find electric field in the plane of the board. Here you don't find electric field perpendicular to the plane of the board. So it is partially polarized. It means polarized to a small extent. Okay, ma? But if I incident light at an angle called Brewster's angle, what is the name of the angle? Brewster's angle. Then I see that the reflected light is 100% polarized. I am not talking about refracted light. Which light? Reflected light is 100% polarized. That angle is called Brewster's angle. Are you able to understand? And based on this one only, we will write Brewster's law also. What is Brewster's law? Right. Clear, ma? Brewster's law. Brewster's law says that. Okay, ma? So this is my first medium, this is my second medium. Refractive index mu1, refractive index mu2. So mu2 divided by mu1 is equals to tan theta b. This is called as Brewster's law. Are you able to understand? So this angle of incidence will be how much? Tan of angle of incidence. Which angle of incidence? At which reflected light is 100% polarized. This is angle of incidence, no? Are you able to understand, ma? So if you take a tan of that angle, then it is equal to the ratio of refractive index of second medium to the refractive index of first medium. Are you able to understand? So here you can write one case also. What is the case? If first medium is air, if first medium is air, okay, ma? Then the mu1 value will be 1, no? If first medium is air, mu1 will be how much? 1. So therefore, tan theta b will be how much? It will be mu2 by 1, or just you can write mu also. So you can write like this also. But condition is what? First medium should be air or vacuum. Then only you can use it. Otherwise you better remember this one. Mu2 by mu1 is tan theta b. Clear, ma? That is called Brewster's angle. See, ma? So polarization by double refraction. See, ma, there are some crystals like calcite. Okay? So on this calcite crystal, if you incident a ray of light, now what is this ray of light? Polarized or unpolarized? This is unpolarized. Clear, no? Then this light, it will split into two light rays. One is ordinary ray, second one is extraordinary ray. Ordinary ray, why it is called ordinary ray? Because it follows all the laws of refraction. Okay? See, initially light is entering from rarer to denser, no? It bends towards the normal. Now it is entering from denser to rarer, no? It bends away from the normal. Clear, no? And this is extraordinary ray, which does not follow any rules. Okay, ma? But point is that both of them, they will make the light to be polarized. Okay? So the vectors which are present on extraordinary ray, they are also polarized. The vectors which are present on ordinary ray, they are also polarized. Both will be polarized. That is the specialty of this crystal called calcite crystal. Clear? Sima. So next we are studying about polarization by scattering of light. What is meant by scattering of light, Sima? The molecules and atoms which are present in the air, they receive sunlight, no? Clear, no? And sunlight is what kind of light? Unpolarized. Unpolarized light, no? So after receiving this energy, then they will scatter light in every directions. They will send light in every direction, and depending on the size of the molecule. For example, if you take a nitrogen gas and oxygen gas, they take every color, but they give only blue color. Are able to understand? That is why sky appears to be blue in color. Are able to understand? అవి అన్ని కలర్లు తీసుకొని బ్లూని మాత్రమే పంపిస్తారు బయటికి. Are able to understand? And they give light in which direction? Every direction. But if you take that light which is making exactly 90 degrees with that of incident light direction, then that ray of light will be exactly 100% polarized. అర్థమవుతుంది కదా? సో అన్ని లైట్ రేస్లో ఒక లైట్ రే which is making an angle of 90 degrees, that will be 100% polarized. Okay? So this ray of light is plane polarized. Are you able to understand, ma? That's it. So